Hello everyone, welcome to our GeoSpatial Techno channel. In the previous session, we discussed the types of different categories and various inputs used in the WPS standard. In this session, we will learn in detail how to use the buffer and intersection analysis in the WPS request builder. For more information, watch the rest of this video. Buffer analysis is a crucial process in Geographic Information Systems or GIS. It involves creating a zone around geographic features such as points, lines, or polygons to analyze spatial relationships and proximity. This type of analysis has various applications including determining influence areas, assessing environmental impacts, and evaluating accessibility. It provides insights for decision-making in fields such as urban planning, natural resource management, and emergency response planning. In GeoServer, users can create buffer zones around geographic features by specifying the input geometries and the buffer distance. This functionality is a part of the GeoServer WPS extension, which provides a standardized interface for various geospatial processing algorithms. To create buffers in GeoServer, navigate to the Demo section and select the WPS Request Builder option. In the Choose Process section, type Buffer to see a list of available buffer-related processes. As you can see, GeoServer has 6 such processes. As mentioned in our previous session, the functions JTS column buffer and Geo column buffer don't directly access to the GeoServer layers. Instead, these processes utilize external libraries, specifically the Java Topology Suite or JTS and Geo tools. From the list, select JTS column buffer. This operation requires 3 inputs for execution: text, reference, and subprocess. In the text mode, you need to enter the geometry data in standard formats. For this example, use the application/WKT as the input format and enter the geometry data as shown on the screen. Enter the buffer distance in the distance text box. This parameter defines the size of the buffer created around the input feature and is represented as a double data type. In this case, enter 0.1 degrees, which is based on EPSG column 4326 coordinate system. Note that the distance value is mandatory and corresponds to geometric units being used. Choose your desired output format from the Process Output section. This enables you to select the most appropriate format for your specific use case or workflow. The result can be further processed, visualized, or used for additional spatial analysis. The available formats include: select the application/WKT format and press the Execute Process in New Page button. Now that you have executed the buffer operation, you can view the results. Navigate to wktmap.com and enter the resulting geometries in the WKT text box to visualize the buffer created around a specified point. Go back to GeoServer software to explain other parameters. The quadrant segments parameter in the JTS column buffer is an optional parameter for shaping quarter circle buffers. Increasing its value enhances the buffer's smoothness and circularity, but also raises vertex count, which can affect performance. For instance, one segment produces a 4-sided polygon. 5 segments create a 20-sided, more circular shape. The default is 8 segments, which create 32 sides that are more circular than the others. It's important to balance precision with processing efficiency, as a higher value improves curve quality but increases computational complexity. Set the distance buffer to 0.11 and quadrant segments to 3, then press the Execute Process in New Page. Now let's see the resulting shape. As you can see, the result is somewhat circular due to the smaller number of sides. Go back to GeoServer again to explain the last parameter, capacity. The capacity is an optional parameter that specifies the type of capacity used at the ends of buffer polygons. There are three available options: round, flat, and square. Round. This is the default option, which creates a rounded appearance at the ends of a buffer around the line feature. Flat. This option creates clean and straight ends. Square. It creates a more pronounced squared off effect. By selecting the appropriate capacity, you can customize the appearance of your buffer areas according to your visualization needs. To use the capacity option, enter the geometry data in the application/WKT format, then enter the distance value as shown on the screen. Press the Execute Process in New Page button. Repeat this process for the flat and square capacity and then view the results. If you're enjoying the video, I would really appreciate if you subscribe to my channel, like the videos, and shared it with your friends. This will help you and others to improve your skills and benefit from these valuable resources. Thank you for your support. GS Column Buffer Feature Collection. This function utilizes the GeoTools library to process feature collections by generating buffered geometries around each feature. Users can specify the buffer distance as either a fixed value or dynamically based on a specific field's value. The input and output parameters for buffer feature collection function are consistent across both GS and WEG categories, ensuring seamless integration into various workflows. The first input parameter is the input feature collection, which can accept four types of input: text, reference, subprocess, and vector layer. The default option is the vector layer. For this example, we will use the ArcSites layer from GeoServer. Select this layer from the Choose One drop-down menu. We will first apply a fixed value for the buffer distance parameter, followed by using a specific field to dynamically adjust the buffer distance. Enter a distance value suited to the coordinate reference system or CRS of the layer. As the ArcSites layer uses the UTM CRS, you can set a value like 20. Note that filling this parameter is mandatory. Once the input features and distance have been defined, choose the output format for displaying the results of the buffering operation. Available formats include: select the application/zip format from the process output section and then press the Execute Process in New Page button. After the process is complete, open the result file using QGIS software. You will see that buffer areas of 20 meters have been created around each feature. Dynamic value buffering. To use a specific field for a buffer distance, first enter a zero value in the mandatory distance box, then specify the attribute name that contains numerical values for the buffer distances. In this example, we will use the cat attribute. Again, choose the application/zipmom type for the output file format and press the Execute Process in New Page button. After processing is complete, add the resulting file to QGIS software. As you can see, the buffer areas around each feature have different distances based on the values found in the cat field. Intersection analysis. Intersection analysis is a crucial spatial technique used in GIS to explore and understand the relationships between various geographic features or datasets. This method focuses on examining how different data layers overlap and interact, which provides valuable insights for decision-making processes in areas such as urban planning, environmental management, and resource allocation. In GeoServer, intersection analysis facilitates the identification of overlapping areas between features from two distinct datasets. This operation can be efficiently implemented through the WPS request builder, making spatial analysis both effective and user-friendly. To carry out an intersection analysis, select GS:"intersection feature collection from the Choose Process menu. The first and second feature collections serve as the main input features and are considered mandatory parameters for this process. Other parameters are optional. For this example, choose SF:"streams as the first feature collection and SF:"restricted as the second feature collection. Select the application/JSON format from the Process Output section, then press the Execute Process in New Page button. After execution, you can view the results by navigating to geojson.io website and entering the resulting geometries in the text box provided. The intersection analysis also allows you to specify which attributes from the input feature collections should be retained in the output. If this selection is not made, all feeds from each layer will be included by default. In this example, enter label to retain this specific field from the first layer. Intersection mode. This parameter allows users to specify how to handle the intersection of two feature collections. By choosing between the intersection first and second options, users can tailor the results to fit their specific spatial analysis needs. Let's describe each of them. Intersection. This is the default option, which includes only the features that geometrically overlap between the two input collections. Only areas where both inputs intersect will be represented in the output. First, this mode filters the first feature collection by retaining only those features that intersect with any feature from the second collection. Features in the first collection without any intersection will be excluded from the output. Second, similar to the first option, this mode outputs features from the second collection, retaining only those that intersect with any feature from the first collection. For this example, we select the first option in the intersection mode parameter. To view the results and incorporate the resulting geometries into ArcGIS, select the application/zip format from the Process Output section. Then press the Execute Process in New Page button again. The output will consist only the streams handle and label feed from the first layer. This means that the output features will only include those from the first collection that intersect with features in the second collection. Additionally, the analysis includes two Boolean options that determine if additional area attributes are included in the output. Percentage enabled. When set to true, this option includes attributes indicating the percentage of each feature's area relative to the total area of each input feature collection. By default, this option is set to false. Areas enabled. Similar to the percentage enabled mode, this option, when enabled or set to true, includes attributes representing the area of each feature in the intersection. Its default setting is also false. By carefully defining the parameters and choosing the appropriate options, users can effectively perform intersection analysis in GeoServer and generate meaningful spatial insights. In this session, we discuss how to use the buffer and intersection analysis in the WPS request builder. To learn more about the different categories and various inputs used in the WPS interface standard, we recommend watching the suggested videos. Have a good time!